Hello, and this is going to be Solidworks CSWA practice problem 7.24. If you want to follow along with the video, make sure to follow the link in the description, which will take you to the official Solidworks practice problem database. So let's get started. First, make sure your units are in MGS, and we're going to start a sketch in the front plane. Now we're going to set our revolve for the cylindrical base, and we're gonna if you notice the rims at the top, those kind of like revolve cuts at the top, you actually don't need to do those separately. You can actually include that inside the revolve itself from the get-go. So let's draw a straight line here, then we'll draw a straight line here, and then I'll draw a couple of pairs of lines like so. And we'll continue until we have about, how many teeth is that? It's 1, 2, and 3. There should be 3 teeth. So we're at 1 now. So 2 and 3, and we'll end it there, and then we'll close out the part like so. But obviously this is not these are not equidistant, so I'm gonna make these 3 gap lines equal, and I'll make these 3 outer edges also equal, and then we're going to dimension them. So first, the total height of this is going to be 90, and if you're looking at the engineering drawing, if you look right below the front view, it's actually showing you what the part looks like if you're looking at it from the bottom. So you're kind of looking inside of the part, which explains why it looks so weird. And you'll notice that 75 diameter, that's saying that the entire cylinder's diameter is 75. And since we're revolving it, this edge will be half of that. So I'm going to click on this edge with the smart dimension, and then I'm going to hold the center line. Well, actually, where did I can't tell where my center, oh, there it is, it's hidden a little bit. I'm gonna raise this. So again, I'm gonna press the line, I'm gonna hold the center line. Oh, weird, usually works. Or maybe it's a point. Maybe I select the point and then hold the center line. Ah, yes, there it goes. So this distance is going to be 75. 75 for your total diameter. And we need to make sure that all these lines are collinear. So that's what we're going to do. Going to say collinear, like this. Perfect. And then we're going to start adding our dimension for the teeth, which you'll see in detail view B. So this length right here, or oh, wait, hold on. So this length right here is going to be 3. And then the width of the gap, which is this line right here, is also going to be 3. And the distance between, or the total width, or the total side width of the teeth like this, is going to be 5. And obviously the other two lines have to match. So I'm gonna control click all 3 of them and make them collinear, like so. There, now you have your fully defined cylinder with teeth. So let's go ahead and revolve this. So say feature revolve plus base, select OK, and there you go. So there's the easy part done. And now we're going to make our 22mm hole, which you'll see in the front view. So start a new sketch in a front plane. Let's make our circle. Let's give it a diameter of 22. Let's make sure the center is vertically aligned with the origin. And let's give it a dimension of center point from the top. That distance is 42. I have a fully defined circle. And the reason why I know this is 42 is because if you look at section AA view, you'll see that the distance from top edge to the axis of this hole is 42. And the axis is the same as center point. So we're going to go to feature extrude cut, and let's just do a through cut both ways. So through all both, select OK. So now you just finished the easy part. Now is for the absolute nightmare hard part. So we're going to be working a lot in the inside here. So it's actually going to help if we change the transparency. So I'm going to right click on revolve, change transparency, and now you can clearly see what we're dealing with here. Okay. Okay. So from here, the very first thing we're going to do is we're going to carve out the inside. We're going to make the inside hollow, but in a specific shape. So let's start a sketch. I guess we'll start a sketch in a front plane, like so. I'm going to make a center line. Vertical center line. That'll be my axis of revolution. And I think we should start from the top, I believe. Actually, no, it doesn't matter which way you start. So I'm going to start, draw a straight line here. I'm going to leave a little gap with the edge, another straight line. And this is just going to go up until... Oh, actually, I forgot to add one more center line. So let me add a center line. Actually, first of all, let me add a point. I'm going to add a point at the center of the circle. And I'm going to draw a center line across this center. And the reason I'm doing this is because if you look closely at section CC view, you'll see how the inside revolve cut is actually constrained. The bottom part, and I know the section view is upside down. I don't know why they did that. They're just trying to throw you off probably. So considering that the view is upside down, the bottom part, that's kind of like the fat part of the cut, it actually ends at this exact line right here. And then the small part starts from this line and then goes up until it's a certain distance from the top edge. So this center line that I just drew is kind of the key to understanding how to constrain the revolve cut. So I'm going to make a straight line. I'm going to put it here. And I'm going to go in a little bit. And we're going to go back out. Straight line. And we're going to stop a distance from the top. And I'm going to close out with a horizontal. Like so. And I'll close out this whole thing with a straight line to close the contour. So now the dimensions. The distance from this long edge to the side is going to be 5. And you're going to get that from section AA. Now this is the complicated part. If you look closely at detail B, the detail B view, you'll see at the bottom of the view that 10 dimension. It's a kind of cut out and it doesn't show the picture clearly, which is what really confused me the first time I did this. But that's actually the top cut part, the top of the revolve cut. I guess we'll call that like the mushroom cut. Like, the distance from the mushroom cut side to the right side is 10. So mushroom cut side to right side is 10. And the reason why it's called a mushroom cut is because of what I'm about to do. I'm going to add a R10 fillet to this corner right here. And there you go, you have a mushroom. And the distance from the top of the mushroom cut to the very top of the revolve is going to also be 5. And now I'm looking back at section AA view. And I believe that's it. Is that it? Yes, that is it. So we're going to make our revolve cut. So feature, revolve cut, choose this is the axis of revolution, select OK. And now you see that it has been cut. And you can see the inside like this. But obviously we have one thing missing, and it's that it's this kind of like hollow cylindrical extrusion from this circle a certain distance this way, and that feature mirrored onto the other side. So that's exactly what we're gonna do. So let's make a sketch. I think we're going to make a sketch in the front plane. First of all, yes, since it is hollow, we're actually going to need to use convert entities. So this will serve as the inner circle. So let's select the whole circle, and we'll click OK. That's how it looks like. And then I'm going to add a concentric circle, like so. And that dimension is going to be 30 millimeters in diameter. And I got this from section CC view. And so now I'm just going to extrude this kind of a ring part so that the inside is hollow. So I'm going to click Feature, Extrude Bus Base. But I'm going to select what should I select? Well, I should start the extrusion possibly from a vertex. Can I do that? Can I start the extrusion from this circle? No, it doesn't look like it. Interesting. Or maybe I could just start it from an offset. So we'll start from an offset. And since the total diameter of the part is 75, I guess we can make the offsets Let me think about this. Let me see. Because I wouldn't want to extrude it. How do I extrude this? Well, if you extrude it from an offset, you need to extrude it a certain way from the offset. So I'm gonna switch to blind direction, and we're gonna offset it, let's say 30, like this. Actually, I'm gonna turn off transparency. It's kind of screwing me over a little bit. So I'm gonna click revolve, change transparency, so I can see what the actual thing looks like. Okay. So from here, let's go back to extrude feature or boss base. Let's click from offset. Let's change that value to 30, and let's reverse the blind. Let's see if this works. No, there's still a little bit of a gap there. Let me offset a little further. Maybe 35 will do the trick. 35. Let's see. Yes, 35 is just inside of the exterior of the cylinder, so it's not protruding outward, but it's also deep enough like this. But I think this is the wrong way to do it. Oh man, what could possibly be the best way to do this? To make this center extrusion. I know in the hints it said, or in the reference geometry it says planes. But why would I need a reference plane to do this? Wait, oh my god, wait, can I just select from surface and select the exterior, like this? Oh, if I select this face, so from surface, and I click blind, does this even do anything? Oh, select the contour. I need to select the contour. So I'll select the contour. Or do I need to select it from the inside? So maybe the face should be this inner face. doesn't seem to be it. Huh. Okay, well, I'm gonna keep my sketch here. I think we need to pull out... I'm gonna pull out a reference plane. So I'm gonna exit the sketch. Let's go to Features, Reference Geometry, select the plane. I guess as my first reference, I'm gonna make a tangent reference with this exterior. And then my second reference, I guess, would be the top plane. I guess that doesn't work. Maybe my second reference should be front plane? Front plane parallel. Yes. Parallel to the front plane, tangent to the exterior of the cylinder. And I'll hide the other planes. So. But my concern here is if I extrude from here, won't it kind of override my circle? That's my problem that I have right now. So I know the distance. Oh man. An offset distance. Actually, no, scrap that, scrap that. Scrap the plane. So I'm gonna just delete that plane. Let's go back to the original sketch. So, okay, I'm gonna go Features, Extrude Bus Base. We're gonna select the sketch we drew. I'm gonna go from an offset. Okay, I'm gonna go from an offset from the front plane in which I drew the sketch in, and I'm gonna put here 13. And the reason I was doing that is because that's half the distance of 26. So that should account for half the gap that's needed between this and the other cylindrical extrusion. And then I'm going to have to extrude it up to next. Did that just work? Oh my god, did that just work? No way. No way. Wait, did that just work? Wow. Wow. Okay, I literally just clicked up to next. I think that's literally the first time I've ever even used up to next. So that's what it does. So if you click up to next for your direction, it actually extrudes the hollow cylinder up until it makes contact with a surface. But in this case, it actually makes contact with two different surfaces. But as you can see from this right view, it actually extrudes up to both of the surfaces, accounting for the difference in elevation. Wow, this is Jesus. What an amazing tool. And so that actually covers everything. Up to next. Wow. So make sure to use up to next more often, because this is insane. I'm gonna use this more often. So there's your first feature, my god. And now all we need to do is mirror that. So I'm gonna show the planes. I'm going to go to linear patterns, click mirror. For the mirror plane, we'll select the front plane. And then for the feature to mirror, open the tree and click the extrude that we literally just did. And it's going to copy the up to next extrusion on the other side. Select OK. And there you have it. Oh my god. Wow. I completely forgot about that. Okay. And I believe that's your final part. Let me double check. Yes. Sorry for taking so long on this. That pause at this cylindrical hollow part is that was really long, but hopefully you found some insight from that up to next trick that I just figured out. So let's check the answer first. So let's evaluate mass properties, and you'll end up having a volume of 148,273 cubic millimeters for your volume, which actually ends up being the correct answer. So, hope you learned something from this video, and I'll see you in the next one.